Elastic limit is a limit that is a maximum limit up till where the body, when deformed, regains its original position. There are three types of stress. Which are those three types of stress? First stress is said to be longitudinal or a normal stress. Second was your hydraulic stress. Third was your tangential stress. Before we had studied previously in modulus of elasticity, that is stress to strain, but here it is ratio of strain to strain. So both the side we have strains. Hello everyone, I am Brinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru. Welcome you all to the session 2 of chapter 9, and chapter name is Mechanical Properties of Solids. In our last class, we had studied regarding the introductory part of the solids and stress, strain as well as Hooke's law. So today in this class, let us study regarding stress strain curve. So the object which is subjected to the stress strain curve is nothing but the one which undergoes tensile stress. So what is this tensile stress? Tensile stress is a stress which occurs when there is a longitudinal stress which is applied. So tensile stress, there is change in its length. So you have got change in length, that is the length increases. There is increase in change in the length of the object. So here in this case we are considering a stress strain curve for a object, that is the one which undergoes tensile stress. So from O to A, here they have marked in red color, that is they have given Hooke's law. So from O to A, that is in OA the stress is proportional to strain. In OA part, what can you say? The stress is proportional to strain. From A to B, it is not proportional. The stress is not proportional to strain. From O to A, you say that the stress is proportional to strain. That means it obeys Hooke's law. Hooke's law states that the stress is proportional to strain. So from O to A, it's Hooke's law. From A to B, it is nothing but stress is not proportional to strain. And at B, we have got a elastic limit, or it is also called as yield point. So what is this elastic limit? Elastic limit is a limit that is a maximum limit up till where the body, when deformed, regains its original position. Above this limit, if the deformed force is applied, then it never regains its position, that is its original position. So this is a limit which is said to be a yield point. In the stress strain curve, it is determined as yield point, and the stress when applied to this yield point, that such kind of a stress is known as yield strength. It is known as yield strength. You mention it as strength. The stress becomes the strength, that is the yield strength. Once the stress exceeds the limit, that is the elastic limit or the yield point, once it exceeds the yield point, then finally you get a breaking stress which later results in fracture point. That is, it gets fractured. The material whichever you are considering breaks down. So it is fracture point. So it's like from A to B, the stress is proportional to strain. How much ever stress you apply, those many strain is obtained in the material, and then from A to B, it again increases, that is the strain increases, but stress is not proportional to strain in case of A and B. At B, it is a maximum limit. When the stress is applied, the strain is occurred, and that is said to be a maximum limit, wherein by the removal of the force again it can regain back. If you are applying a stress which is more than the limit, which exceeds the limit, then the material undergoes a breakage. That is said to be a fracture point, wherein its orientation is completely changed. Okay, so here E means it's a fracture point, which is also known as breaking point, where the breakage can be seen. Okay, this is all about your stress strain curve, and for this we can consider an example of a wire or a spring, that is O to A means the spring is stretched and it is restored back. The restoring force occurs. When the restoring force occurs, you can say that the spring is lying between O to A. On further increasing in the load, what happens to the stretches downwards, correct? So when it stretches, when the length is changing, there is change in length, that is tensile stress. So as the load increases and the stress is increased more than that of the limit, then the wire or a spring gains a permanent change in length, that is permanently its length is changed, it will never regain back. And furthermore pressure, that is furthermore stress is exerted on the same wire. What happens to the wire? It breaks. There is a fracture occurred. So that is nothing but this fracture point which is represented by this curve. Now let us go to elastic moduli. So we have that proportionality constant in Hooke's law is said to be elastic moduli. So we can say that stress is proportional to strain, and we have stress is equal to K into strain. So this K is known as proportionality constant, which is termed as modulus of elasticity. And we know there are three types of stress. Which are those three types of stress? First stress is said to be longitudinal or a normal stress. Second was your hydraulic stress. Third was your tangential stress. There are three types of stress. According to those three types of stress, we have got moduli of elasticity. Which are those moduli? So we have got Young's modulus, which is given by Y, and bulk modulus, which is given by B, and shear modulus or modulus of rigidity is given by eta. Okay, these are the symbolic representation of three types of moduli, wherein Young's moduli means it is associated with longitudinal stress, which we had studied in the previous session, and bulk modulus is associated with hydraulic stress, and shear modulus is associated with, that is modulus of rigidity is associated with tangential stress. So these are the concepts of the moduli of elasticity. There are three types. One is bulk, one is Young's modulus, another one is shear modulus or modulus of rigidity. So in this case, when we just consider, let us consider this Young's modulus. It means the ratio of longitudinal stress to the longitudinal strain. I told you we are considering the longitudinal stress over here. So again we are considering the longitudinal strain. So Young's modulus, which is determined by Y, is stress by strain. So it is nothing but we have longitudinal stress given by sigma is equal to force per unit area, because longitudinal stress means it is force which is acting perpendicular to the object. So when there is a force which is acting perpendicular object, there is a development of restoring force per unit area. This is said to be a longitudinal stress. So what is that longitudinal strain? It can be given as change in length to the original length. Strain means there is change in the orientation. What is that orientation? The length. The length changes. In strain, either length will change or else volume will change or else its shape will change. So here there is longitudinal strain. That means there is change in length. You got to know the concept of strain. Under strain, whatever we have studied is change in shape or the longitudinal strain, and we also have change in volume, which is called as volume strain. So here we are talking about longitudinal stress as well as longitudinal strain. So we have sigma is equal to F by A, and we have delta L divided by L for the longitudinal strain. So when you consider the ratio of these two, so it will be Young's modulus Y is equal to ratio of these two, that means F by A divided by delta L by L, which can be given as F by A and L by delta L. So that is all about your Young's modulus. So after this, let us go to the shear modulus. So what is that shear modulus? It is ratio of tangential stress to the shearing strain. Okay. So what is the tangential stress? It is nothing but the force which is applied on a body tangentially. So tangential stress we have got it as Restoring force per unit area because it's the definition of the stress, and shearing strain. What is that shearing strain? Shearing strain means change in its shape. So when it is change in shape, what do you give? It is like delta L by L, that is the length changes. So here I can consider as theta is equal to delta L by L, change in length to the original length. So when this is a case, I can consider it as shear modulus, which is given by eta, or it is also called as modulus of rigidity. It is given by ratio of stress to strain. So when it is stress to strain, I have got eta as F by A into L by delta L, same as that of the Young's modulus, and where the shear stress is smaller than that of the Young's modulus, which is given by eta is equal to y divided by 3, and eta lies between 0.2 to 0.4. So this is all about your shear modulus, or it is also called as modulus of rigidity, which is given by eta. So next let us consider regarding the bulk modulus. So what is this bulk modulus? How is it given? So usually in bulk modulus, which is related to the hydraulic stress, whatever we have studied. So what is that meant by hydraulic stress? Hydraulic stress means overall to the surface uniform external force is applied. So external force, that is the deformed external force which is applied, is always uniform throughout the body, which is given in this diagram. So this is the original volume of the object, that is light shaded color with volume V, and the compressed one is given by a dark shaded color, wherein these arrow marks are the one which suggests that it is a deformed force which is applied on an object. So when the deformed force is applied on an object, what happens to the ball? It decreases in size, that is its volume decreases, that is its volume changes. Okay, so in case of bulk modulus, you can consider it as B is equal to hydraulic stress to strain. So ratio of stress to strain, it is with strain and with stress, it is hydraulic stress and volume strain. So in order to consider hydraulic stress, what do we consider? It is usually restoring force per unit volume, the same formula for all the three stress, but it applies like how the force is applied, that's all. That is all the changes which is undergoing in three types of stress, but restoring force per unit volume is one and the same. Types of stress is applied in too many different ways. One is applied perpendicular, one is applied tangential to it, the other one is like throughout the volume of a object. Okay, so that is uniformly applied deformed stress, that is nothing but hydraulic stress. So bulk modulus is equal to, it is defined as the ratio of the stress to the volume strain. So it becomes volume strain is delta V by V, which can be changed to F by A into V by delta V. This V goes upwards towards the numerator. So we have this equation. For here, what happens to the volume? So considering the hydrostatic pressure, compression of hydrostatic pressure. So this is P. Here consider the compression of hydrostatic pressure. When you consider that the hydrostatic pressure which is present in a sphere is compressed, what happens to it? That is, B is equal to, pressure is nothing but force which is exerted per unit area is said to be pressure. So I can consider the whole term as P. So it becomes P into V by delta V. So this will be negative of it because it's getting compressed. It is getting decreased. When the pressure increases, the volume of an object decreases. So that is why we have got negative. So this is said to be the bulk modulus expression. So you have got a compression. So what is that compressibility factor? Compressibility means it is reciprocal of this bulk modulus, which is given as, compressibility is given by K, which is equal to 1 by P, that is minus 1 by P, it is negative, and it is delta V by V. So how can you define this compressibility factor? It is nothing but change in the volume per unit increase in the pressure. So change in the volume which is taking place per unit increase in the pressure is said to be this compressibility factor. So this is all about your bulk modulus. After this bulk modulus, let us go to the next topic, that is Poisson's ratio. Poisson's ratio means within the elastic limit. For Hooke's law and Poisson's ratio we are considering, that is inside the elastic limit, Poisson's ratio as well as Hooke's law holds good. That is, in a curve you have got the equation, here will be a fracture point and here will be a yield point, where from here to here it is known as OA, and this obeys good for the Hooke's law. Similarly, the same thing applies to the Poisson's ratio. Within that elastic limit, the ratio, a law occurs that is said to be a Poisson's ratio. So within that elastic limit, the ratio of lateral strain to longitudinal strain. So this is a length. Suppose you consider a wire. This can be said as length and this can be said as the diameter. So this length is termed as longitudinal and this diameter is termed as lateral. So here, suppose if you are considering the magnified image of a wire, so it is extended, so this can be the diameter, so it is a lateral, and this can be the longitudinal, that is the length, so it can be longitudinal. So it is strain and strain, ratio of strain to strain. Before we had studied previously in modulus of elasticity, that is stress to strain, but here it is ratio of strain to strain. So both the side we have strain. So Poisson's ratio is considered to be a sigma divided by what kind of strain, that is lateral strain to a longitudinal strain. When it comes to lateral, that is strain means changes to the original, ratio of change to the original one. So why I am considering D? Because here I am calculating the diameter of it. So diameter changes when the wire increases. When a wire, that is a solid wire's length increases, what happens to its diameter? It concises. So there is decrease in the diameter. So there is change in the diameter. So I can consider as delta D divided by D and to the longitudinal strain. Longitudinal means something which is with the length. So you have got delta D divided by D into L divided by delta L. So sigma is equal to delta D divided by D into L divided by delta L. That is all about that. Delta means that change in the length. So this is all about your Poisson's ratio. I hope you are clear with the Poisson's ratio. So what is that Poisson's ratio? It's a ratio of lateral strain to a longitudinal strain. So next, let us go to the elastic energy. So what is that meant by elastic energy? It is the energy which is associated with elastic materials. So what is that elastic material or the property elasticity? Once the force is applied to it or applied to an object, what happens to an object? It undergoes deformation, and then by the restoring force, it comes back again. That means it gains the original shape. Such property of a body is known as elasticity, and the material which exerts this elasticity property is known as elastic material. So here we are studying elastic energy, something which deforms and regains its position, that is known as elastic materials. So here we know that mechanical energy means it is of two types, that is kinetic energy and potential energy, wherein here you can see by looking at this image, you can see that there is a kinetic energy as well as a potential energy when the material is said to be elastic. That is, when a wire is stretched, there is some work done against the internal restoring force. So when you just pull the bow and arrow, suppose you consider a bow and arrow and you just pull this bow, what happens? You're just giving the potential energy to the arrow. So here there is a energy which is stored just before the work is done. So certain energy is stored over here before you leave the arrow, and the movement of the arrow will be the kinetic energy. So this energy is said to be potential energy. What sort of a potential energy? It is elastic potential energy, because the wire which is present over here, that is this wire, what you can see is said to be elastic material. That means it possesses elasticity. So this elastic material possesses certain energy during this posture, that is elastic potential energy. So here ends our chapter 9, that is mechanical properties of solids. So today in this class of this session, what we have studied regarding the stress strain curve, elastic moduli, that is 3 types, which is bulk modulus, Young's modulus, as well as shear modulus, which is also called as modulus of rigidity. After that, we had studied regarding the Poisson's ratio, that is stress by stress, that is lateral stress to the longitudinal stress, and we got to know how exactly the Poisson's ratio is applied. And later on, we studied regarding the elastic behavior of the properties and what is the energy which is associated with the elastic. Regarding that, we had studied. So let us all meet in our next class in the next session with a new chapter. Until then, have a good day. Thank you.